So what I want to do is I want to learn two separate models of the same stone into one stone. So I did some scanning with the backhead of the stone, and for first I load the two independent models into one Cloudcompare project. So we see both of them showing the same stone, one the top, one the bottom. A is the top side. So first of all we have to crop it to the actual part of the model that we want to keep. This we do like this, and then the same thing for the other side. With the scissors tool, we select the part we want to keep, we apply the selection, and we delete the undisplaced. And the number B, it's orientated from the wrong way, so we use the transform tool, and we rotate in a way that the markers more or less align, and we can move it with the right mouse button to the correct location, and we apply this transformation. We zoom in a little, and we select both of our objects and use the alignment by picking point pairs. A is a sample one, and then we just click 2 points on each model, rotate, click point number 2 on each model, rotate, and click point number 3 on each model. Then we can align the two models to each other, and if this looks correct, apply the alignment. See that the scale transformation is like minimal. So now we're more or less done. We have to duplicate both of the models before we can merge them into one model. Now we have a merged mesh, and this one we can save already. So I make a new folder for that. And in this I save the merged mesh. And if we look in the Explorer, we see that we have a merged mesh, the materials file, and two texture files from the upper and from the lower one. So we open this up, we will see that we have a textured file, which is nice for the use of 3D software. But problem is that our mesh so far is not watertight, so if we want to calculate the volume, it will not be possible because it's actually still two meshes overlapping each other. So what we will have to do in the next step is we select the vertices of our merged mesh, and we have to calculate the normals. It's a triangulation mesh, so make sure you choose triangulation here. We apply this, and the normals are calculated. So, and in the next step, we can use the Poisson reconstruction to make a closed mesh. So this might take a second, and what we see is we have a closed mesh now, which doesn't contain any textures anymore, but at least we have a mesh that looks correct. This one we can save it as well. And so in our folder we have now the materials file, the original merged mesh with the textures, and a watertight merged mesh without textures, but that we can use to calculate the volume of our object. To do this, we would open MeshLab and load our mesh inside, and if we now go and see the mesh itself, we can do some calculations on it. For example, the quality geometric measures, and we will see we get a mesh volume that we then can copy and use for other purposes. And we could also, in this case, for example, do some remeshing, for example, make a low poly out of it for the use in, I don't know, reconstruction things. We can see that this is a low poly mesh. And if we want to export this, then we have to export it as, let's say, and you will see that it just exports the vertices and no textures at all because we lost the textures in the process. So this would be our final result for now. And we continue playing whatever.